Good morning. Welcome to Lionheart Academy. We're here in our trigonometry lesson. Today we're on trigonometry lesson 29. We have been talking about graphs of trigonometry functions, how to sketch a sinusoidal graphs. Last time we have done several examples. Today we're going to continue just as a point of review. Let's do one more time. Let's do one more example. Okay. So f of x equal to, let's do negative 3. Now let's use cosine. Okay, cosine, let's do 2x plus 5. Okay, 5 pi. And let's do minus 2. Okay, so basically this time we're going to do everything here. So again, we have several things we need to identify: A, B, C, D. So let's identify our A, B, C, D first. A is negative 3, B is 2, C is negative 5 pi. Now again, the formula is Bx minus C. Therefore, this number should be followed by should have a negative sign in front of it. But right now it's a positive sign. That means the C number is the opposite of what we're seeing here. And D is equal to negative 2. Alright, so all those four things will give us plenty of information that we need. Alright, so amplitude. The amplitude is equal to the absolute value of A. So in this case, it's absolute value of negative 3 is 3. Alright, the period of the function of this graph will be 2 pi over 2. So the period is going to be pi units long, and the frequency is going to be reciprocal of that. It's 2 over 2 pi, so it will be 1 over pi, so reciprocal of that. Now the phase shift, which is the beginning of the beginning, I know I've been calling these two things, beginning of period, or another word, phase shift. Okay, I know I've been calling this two different things, but they are actually the same thing for our purposes. So it's C over B, the phase shift is C over B. Alright, let's move this. So C over B, that means this is negative 5 pi over 2. So the phase shift is negative 5 pi over 2. Okay, we're going to be able to use that. And the ending of the period, of the first period that we're going to graph is going to be C over B plus 2 pi over B. Alright, so that will be negative 5 pi over 2 plus pi. So let's go ahead and add this up. Now pi is the same as 2 pi over 2. So it's negative 5 pi over 2 plus 2 pi over 2, so it will be negative 3 pi over 2. That means we're going to start with negative 5 pi over 2 and complete at negative 3 pi over 2. Alright, so now we are ready to go. And oh, of course I forgot to mention the vertical shift is D. So vertical shift is equal to negative 2. Okay, so there we're shifting down. Alright, so let me go ahead and construct the coordinate plane, and then we can go ahead and try to graph it. Okay. Alright, so now let's take a look at the coordinate plane I just constructed. Okay, I only actually marked the y-axis. I started my axis as negative 2. Now why is that? Because that's where my vertical shift is. So what I will do is I want to draw a dashed line. Okay, this is not part of the graph. I just want to draw a horizontal dashed line going through negative 2, because this is my midline. Okay, I'm going to write this midline. Okay, midline is always very important. We have to mark the midline. And now let me go ahead and mark the x-axis. The x-axis, now we know we started with negative 5 over 2. Now 5 pi over 2, which is negative 2.5 pi. Okay, so I'm going to use 1 pi as my unit. So 1 pi, 2 pi, 3 pi. Okay, that's my 3 pi. Alright, negative 1 pi, negative 2 pi, negative 3 pi. I'm going to try to be as equitable as possible. Okay, so negative 5 pi over 2 is right here. Next, negative 5 pi over 2. Negative 3 pi over 2 is right here. Negative 3 pi over 2. So that's going to be the beginning and the ending of my first period. Alright, and then once we identify the period, once we identify the periods, we need to divide the first period into 4 equal parts. Okay, so this is negative 2 pi, so this will be negative 2 and a quarter pi. This is negative 3 and negative 1 and 3/4 pi. Okay, this is halfway between those two. Alright, So now we are having a negative cosine, right? So cosine starts with the maximum value, but the negative cosine starts with the minimum value. Now my amplitude is 3. That means I'm gonna my maximum and minimum is going to be 3 units away from the midline. So it will be -5 and 1. So it's like +3 and -3 from the midline. Now because it's negative cosine, so I'm going to start at the minimum. So at -5 pi over 2, I will start at -5. At -3 pi over 2, I'm going to start and I'm going to go back to -5. At halfway through 2 pi, I will go to the opposite, which will be positive in this case. The maximum in this case, okay, and halfway between them, they are going to pass through the midline. So this will be my rough sketch. Okay, as you can see, I try to connect the dots using a smooth curve. Okay, like this. So that will be one period of the sine. Okay, now where does the next period start? Well, it seems that every period is pi, right? So from -5/2, -3.5, this is -pi. The next one will be -pi over 2. So it's going to be from -3 pi over 2 to -pi over 2, and that will cut that the whole period into 4 equal parts as well, and that will continue the pattern as I have seen before. So just keep continuing the pattern here. Alright, and then so I have dropped 2 periods. Usually we can stop after we drop 2 periods. I mean, I can keep going, but that will give us a good idea of how to sketch the graph. Okay, so again, this is a review for what we have done last video. If you need more examples, please, and explanations, please go ahead and review the previous video, lesson 28. But today, we're going to go on and to do the other things, which is looking at the graph and then come up with the equation. Looking at the graph of sinusoidal function and come up with an equation. All right. So let's go ahead and turn the page. So how do we write the sinusoidal equation from the graph? Basically is how do we identify the amplitude? How do we identify the period and frequency by looking at the and the phase shift by looking at the graph? Now, as you can see here, our graph the graph, as you can see, keeps continuous going. So this is only a certain section, the middle section of the graph. And so let's go ahead and talk about how we can identify several things. Okay, now how do we identify the amplitude? Okay, now in this case, there are several ways to identify the amplitude. Again, the amplitude is the distance from the midline to the maximum or midline to the minimum, and or it's half the distance between maximum and minimum. Okay, so if you go ahead and do maximum minus minimum, okay, and then divide by 2, that's one way to identify the amplitude. So the distance amplitude is simply from the maximum here. Excuse me, I'm not drawing very straight here, right? So let's go ahead. This distance is your amplitude from the maximum. Okay, if you go from the peak all the way to the midline, but I guess you have to be able to identify where the midline is, right? So from the maximum to the midline, this is your amplitude. Okay, so this is one way to measure your amplitude. The other way is go from the midline, right? Go from midline to the trough, okay, to the minimum value. That is also your amplitude. Okay, but also it means that if you go from the maximum, right, if you go from the maximum peak all the way to the minimum trough, okay, that distance will be 2 amplitude. Basically that's what we're saying. Okay, from the maximum to the minimum, that's 2 amplitude. So in this case, we can identify what the maximum value is. The maximum value, the y value, okay, not x value, but the y value, the maximum y value, okay, y value, so it's going to be 2. The minimum y value in this case is -2, as you can see. Okay, so the amplitude will simply be 2 minus -2 divided by 2. So 2 minus -2 is 4. 4 divided by 2 happens to be 2 as well. Okay, now how do you identify the midline or the vertical shift? The midline of the vertical shift is going to be equal to the distance, the average of the maximum and the minimum divided by 2, or the average. is going to be the average of minimum and maximum. So the midline, as you can see, is in the middle. Okay, it's halfway between maximum and minimum. So how do you get that? Is you take the peak, you plus the trough, and take those values, divide by 2. So in this case, it's 2 plus negative 2 divided by 2. But 2 plus negative 2 is equal to 0. So 0 divided by 2 is 0. As you can see, the midline in this case is 0. Okay, let me highlight the midline for you just in case you need to see it. Yeah, that's the midline right there. Okay, this is y equal to 0 is the midline. And of course, this is the absolute value of A here, and midline is D. Okay, in our lettering using our equation, that's A, that's D. Alright, so that's pretty good. What about period? Okay, the period is this. Okay, the period, there are several simple ways to identify period. Period is how long it takes to complete one cycle, right? But how do you determine what's one cycle? Well, you count from peak to peak. From peak to peak, okay, the time it goes from peak to peak, that will give you the period. Okay, that will give you the period. So let's go ahead and take a look at this peak. This peak is right here. Now this is halfway between 0 and pi over 3, so that's pi over 6. And the next peak, it hits the next peak right here at this time. But when is this time? Well, that's halfway between 2 pi over 3 and pi, right? So if we count by pi over 6, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This would be 5 pi over 6. Okay, counting from peak to peak, this is 5 pi over 6. So the distance, in this case, our period, would be 5 pi over 6 minus pi over 6. So that's 4 pi over 6, but 4 pi over 6, I can reduce that. Reduce it by 2, so it's 2 pi over 3. So the period would be 2 pi over 3. Now remember, period is 2 pi over b, right? So b would be 2 pi over the period p. Okay, let's go use the letter p to indicate a period. So the letter b, remember for our equation, okay, it's going to be 2 pi over 2 pi over 3. So the 2 pi cancels out. This is equivalent to 2 pi times the reciprocal of 3 over 2 pi. So 2 pi cancels out. So the answer is 3. So the letter that we have for our b, okay, that constant will be equal to 3 in this case. Now, is there anything else we need to do? Well, there's a phase shift. Okay, the phase shift. Phase shift is equal to C over B. Now, phase shift is actually quite flexible because, as you can see, if we just look at this graph, right, can you tell it's sine or cosine? Well, perhaps you can say sine because we start at 0. But it could be a cosine if I shifted pi over 6 units, right? So you see, in sinusoidal graphs, you can actually identify this graph with a number, a lot of variations of equations. Okay, we don't have to use sine, we don't have to use cosine, we could use both. But of course, the other things will happen to be different. But right now, we want to go ahead and start with the simplest combination. We don't want to do something too complicated. So if you can see that, okay, this graph starts with 0 and goes up, so I think I can use a positive sign. So if we use a positive sign, then there's no phase shift because we started with 0. Because the beginning of the phase, if we start at 0, then C over B will be equal to 0, and that means C has to be equal to 0, so there will be no C. So in this case, we got A, B, and C, D. We identify all three numbers, and we talk about that we're going to use sine function. So the equation for this function would be the amplitude. Now, of course, you can, because it goes up first, so we're going to use a positive amplitude. So let's go ahead and use A equal to 2, and it's going to be sine, and B was 3, right? 3 pi. Now C, there's no phase shift, so I don't have to write anything, and there's no D, there's no vertical shift. So this would be my final answer. This would be an equation that will fit this graph. That will, if we graph this equation, we'll see something like this. But there are more answers. There are more correct answers here. I can shift this, or I can write the cosine with a pi over 6 shift. Okay, because if I start with pi over 6 2, that means I start with the cosine and going down. So this is a positive cosine, but then there's a shift of pi over 6. Okay, so let me go ahead and just show you that. If using cosine, then the shift, which is C over B, will be equal to pi over 6. So that means I have to solve for C. Okay. Now, but because I already know b is 3, right? So c is equal to b times pi over 6, so which would be equal to 3 times pi over 6, which would be equal to pi over 2. Okay, so there's a phase shift. So if I'm using a cosine, then I will write like this. Still, I'll use 2. Now, cosine, this is a positive way the cosine goes. Cosine starts with 1 and goes down, so it's a positive cosine. It's not a negative cosine. Negative cosines would start from the minimum going up. Positive cosines start from the maximum going down to the minimum. And 3 pi is still the same, but now I need to minus c, which is pi over 2. Okay, so these two equations are equivalent. They are equivalent. And you can use either one to represent this graph. It really depends on how you want to do it. But as you see, if we use cosine, we have to have a phase shift, horizontal shift that have to be taken into consideration. All right, let's go and try another example. Okay, so take a look at this. Alright, so as you can see, there are several things we can do. First of all, we want to identify the maximum value. Okay, so what's the maximum value? It looks like 1. Okay, and the minimum value looks like equal to -1. Okay, right here. So we want to identify our a, the amplitude. Now we're going to go ahead and use absolute value a first, because we don't know which one we're going to use, because we can start at different places. But a should be equal to 1 maximum minus the minimum divided by 2. Right? So it's 2 divided by 2, so it's equal to 1. So amplitude is 1. What about the midline? Midline is 1 plus -1, the maximum plus the minimum divided by 2, so it's 0 divided by 2. And in this case, it's 0 again. Right. Then what about the period? Let's go ahead and identify the period here. So, identify the period, we can go ahead and count from peak to peak, or we can count from trough to trough. Alright, so this time let's go ahead and count from trough to trough, but because I can see trough to trough a lot clearly. Okay, so from this trough to this trough, okay, that's from 0 to pi, so the period is pi. Okay, cool. And so b is 2 pi over p, the period. So that means it's 2 pi divided by pi, so b should be equal to 2. Great. And the midline is 0 here, the period, so that we only need now, we just need to determine the phase shift. But the phase shift depends on which function and which function we want to use and where we want to start. Now, if I use sine, I can start from 0, but then, I can't start from 0. If I use sine, I would start from pi over 4. That would be a positive sign. Okay, so the phase shift would be pi over 4. C over b will equal to pi over 4, and I can solve for c. If I start with 0, I can use a negative cosine. Now, why is negative cosine? Because negative cosine starts on the minimum. If I start with pi over 2, I can use a positive cosine. Okay, so it really depends on which one you want to start, where you want to start with. So, let's start with pi over, if you want to start with 0, it will be a negative cosine. So let's start with 0. Okay, it's going to be a negative cosine. So let's say call this 0. So that means c is equal to 0. So we don't have any phase shift and we don't have any vertical shift. So in this case, it will be f of x equal to negative. The amplitude is 1, so it's -1 times cosine, and b is 2 pi, and there's no phase shift, so it's just negative cosine 2 pi. Alright, so that's one way to start with 0. Now, what if we start with pi? What if we want to use a positive cosine? Okay, use positive cosine function. If we use positive cosine function, the phase shift c over b would be equal to pi over 2. So b is 2, right? So that means c would be equal to 2 times pi over 2, which would be pi. So that means our function would be f of x equal to a positive cosine. B is 2 pi minus pi. 2 pi x, I forgot. Oh, I'm sorry. It's not 2 pi. I made a mistake. 2x. I'm sorry. 2x minus pi. Okay, there's no vertical shift, so it's 2x minus pi. So those two equations are the same. Now, if I want to use sine, the sine function, my shift would be pi over 4. Because I'm not starting at 0, I'm starting at pi over 4. So c over b would be equal to pi over 4. That means c would be equal to 2 times pi over 4, which is pi over 2. So that will give us, our function would be sine 2x minus pi over 2. So they are all equivalent functions of the representing, they all have the same graph. Now, why do I use a positive sign? Because if I go from pi over 4, it goes up and then comes down, so that's a positive sign. Okay, so there are several ways to go ahead and do that. Now, let's try one more. Alright, so let's take a look at this one. Now, this one is a little bit different because there's no pi here on the x-axis, as you can see. But we'll still go ahead and do it. Let's go ahead and do the same way. Let's identify the maximum. Maximum is 2, and the minimum value is actually 0. It goes down to 0. So the amplitude probably could be different, right? So it's 2 minus 0 divided by 2 is the maximum minus minimum. So it's 1. Now, the midline definitely will be different because the midline is 2 plus the maximum plus minimum divided by 2, so the midline is also 1. So let me go ahead and draw the midline here for you guys to see. Midline will be 1. Okay, so this is the new midline, so there is vertical shift. Y equal to 1 is the midline. Okay, now what about the period? The period, let's go ahead and count from peak to peak. Okay, peak to peak from 2 to 1, that's 1. Period is 1. So that means B, the number B is 2 pi over P, right? So it's 2 pi over 1, which is 2 pi. Okay, so B has a pi in there now, which is not uncommon. Okay, and as you can see, when B is equal to 2, has a 2 pi, the divisions we all have using real numbers. Now, okay, then we have to decide what function we want to use and then where we want to start to determine the phase shift. So again, the phase shift depends on C over B, depends on where we want to start and which function we want to use. Let's see. So if I want to start from 0, I don't have to have any phase shift, and it will be a cosine function. Do you recognize it's a cosine function? It starts from the maximum and then go toward the minimum. That would be the easiest way. So let's go ahead and use that as a positive cosine function. Okay, this is starts at 0, right? If we start at 0, it's going to be a positive cosine. So it will be, the amplitude is 1, so it's 1 cosine. B is 2 pi x. Okay, don't forget the x. And then there's no phase shift, so it's just 2 pi x. Okay, and oh, I forgot the vertical shift, plus 1. That's right, vertical shift plus 1. Okay, now if I want to using a positive sign function, I would have to start from this point. This point is a good point to start because that's the first time I have a positive sign. So, but this point is 3/4. Okay, 0.75, 3/4. So let's go ahead and see how we can do that. So use a positive sign function. Positive sign function. That means our phase shift. Hold on. The phase shift C over B would be equal to 3/4 to the right. Now, so far I have all been doing shifting to the right. So C over B is a positive 3/4, and so C would be equal to 3 times 2 pi over 4. 3 times 2 pi over 4, though that is 3 pi over 2. Okay, 3 pi over 2. So my function would be f of x equal to sine, because the amplitude is 1, positive, so and there's a positive sine function, goes up and comes down. Okay, and b is 2 pi x, c is 3 pi over 2, so it's minus 3 pi over 2 plus 1. So this function would be the sine function that will give us this exact same graph. Alright, so I think we have done a lot of practice today. It will be good for you to go ahead and try just playing around with this and practice some more, looking at the sinusoidal graph and then determine the amplitude, the period, the midline, the frequency, the phase shift, not the frequency, I'm sorry, the B is kind of like frequency number, phase shift, and the determine the equation. So there's a lot of variations that we can play around with this. If you have any questions, please leave in your questions in the comment and question section, and hope to see you next time in our next lesson.